Kitten, sir.
So very good morning, all of you.
Good morning, sir.
Good morning, sir.
Previously, we discussed about high performance computing and parallel computing and distributed computing. Today, we will go for cluster computing. Yes, ma. Is it visible?
Yes, sir.
Okay. So we have many paradigms like high performance computing, parallel computing, distributed computing, cluster computing, grid computing, nano computing, biocomputing. So today we'll learn about cluster computing. So first of all, what is the cluster? Cluster is a widely used term meaning independent computers combined into a unified system through software and networking. You know, cluster means we are combining the independent computers. We are combining different computers, independent computers into a unified system through software and networking. Through software and networking. For suppose if we take our lab itself, you know, or any of one of the lab, those are all the cluster computers because those are all the individual computers, and those individual computers we are combining into a unified system by using networking. Those are all the cluster computing. And nowadays, previously in last semester only, the JNTU has also released the clustered colleges. Released cluster colleges like Medchal area all colleges comes under one cluster, and Lingampalli area all colleges comes under one cluster, and Ibrahimpatnam area all colleges comes under one cluster. Like that, they made different clusters, and they are utilizing their services from one cluster to another cluster. That means if our Medchal college cluster, if Medchal college cluster are connecting with the other Ibrahimpatnam college cluster or Lingampalli college cluster, and they are interchanging their faculty, and they are conducting their lab exams. Okay, na? For that purpose only, they distributed different clusters. They made different clusters. So the main concept cluster is a widely used term meaning independent computers combined into a unified system through software and networking. Clusters are typically used for high availability, for greater reliability, or high performance computing to provide greater computational power than a single computer can provide. You know. So by using clusters, if we connect all the independent systems together, combined together, then we will have greater reliability, high availability, and the computational power also very high compared to the single computer. Compared to single computer, the computational power also very high. And clusters are composed of many commodity computers linked together by a high speed dedicated network. So those all independent computers are combined together, linked together with a high speed dedicated network, and will work under that. Next is the cluster categorization. We have different clusters. Those are high availability clusters, load balancing clusters, high performance clusters, and grid clusters. High performance clusters and grid clusters. First one is high availability or failover clusters. High availability or failover clusters. These clusters are designed to provide uninterrupted availability of data or services to the end user community. These clusters are designed to provide uninterrupted availability. There is no interruption at all that they are providing by these high availability clusters. These clusters are designed to provide uninterrupted availability of data or services, whatever it may be, either data or services to the end user community. Next, if a node fails, if we connected different independent computers to a one single network. So in that, if a node fails, means here the node means computer. Okay, na? The node means computer. If a node fails, the service can be restored without affecting the availability of the services provided by the cluster. Yeah. If one one system fails, one computer fails, or one node fails, then the services can be restored without affecting the other systems. Those services can be restored without affecting the other systems, and that services provided by the cluster. While the application is still be available there will be a performance drop due to the missing node. The application is still available in that computer only, then there is a performance drop due to the missing node. Next is the purpose of these clusters. The purpose of these clusters is to ensure that a single instance of an application is only ever running on the cluster member at a time. The purpose of these clusters is to ensure that a single instance of an application. The purpose of these clusters is to ensure that a single instance of an application is only ever running on the cluster member at a time. But if and when that cluster member is no longer available, the application will fail over to another cluster member. If that application, if that cluster member is not available, if that application or if that cluster member is not available, then only the application will fail over to another cluster member or another system or another computer. It will transfer to other system. So this is the architecture of the high availability cluster. We have different email servers, and first uh, at the time of working those servers, we have load balancer primary. You know. So if any backup required, then we attach that load balancer backup. If any server crashed or if any server failed, then that stored information will comes to the load balancer, and load balancer will back up that data. Load balancer will back up that services and stored in that. So when the user want that information, then they can retrieve easily by that. So this is the architecture of the high availability cluster. Next, high availability cluster implementations are used for mission critical applications or databases, a mail, file and print, web or application services. Provides on cluster storage. Those services are those data what is in the node 1, that is transferring to the node 2. Then node 2 is storing that information in cluster storage. Okay, now in this way, that if one node fails, then automatically it will transfer to the another node, and that will store that data without affecting, without losing any information. Next is load balancing clusters. Next is load balancing clusters. This type of cluster distributes incoming requests for resources or content among multiple nodes running the same programs or having the same content. This type of cluster distributes incoming requests for resources or content among multiple nodes running the same programs or having the same content. That means, for suppose if we use Facebook, first the users are only 1,000, then at that time only one server is running. So if the users are increasing rapidly, then automatically the servers also increasing. That means backend load balancers are there in that server. Load balancers are there in that server, and that load balancer will connecting other servers like that. For suppose if one server is having only 1,000 capacity, then another server is having 2,000 capacity. If the users are more than 1,000, then automatically that load balancer will connecting from 1,000 server to 2,000 server. Then after, if the users are increased 3,000 above, if the users are increased 3,000 above, then that load balancer will connect another server. That load balancer will connect another server, and like this, in this way, their load balancers are working. So load balancing clusters means this type of cluster distributes incoming requests. Whatever the requests that those are coming to that cluster, it will accept that request for resources or content among multiple nodes running the same programs or having the same content. Right? Both high availability and load balancing cluster technologies can be combined to increase the reliability. These both clusters are can be combined to increase the reliability of the performance and availability and scalability of application or data resources that are widely deployed for web or mail or news or FTP services. You know, whether when we have deployed any web application or something, at that time these clusters these clusters improve the improves the reliability and improves the availability and improves the scalability of your application. But suppose if you develop any web application, if you developed any web application and that web application you uploaded, you deployed in the cloud. That means, for suppose if we take GoDaddy.com, in that like that .com, if we deployed any web application, so after that your web application you have given for the limited users. For suppose if we given only 50 users, but that web application at a time 1000 members are using, at that time 1000 members are using, then automatically these high availability and load balancing clusters give your server connection to another server, give your server connection to one server connection to another server connection, and they will use that web application. If there is not available any server, then that automatically that web application will slow. It will not open fastly. That's why if we take any web applications, or if we, for suppose if we take our JNTH web application only, at a time 1000 users, if we use that web application, automatically that server will goes down. Automatically the server will goes down. So that's why in cloud we are using load balancing clusters to balance the servers. If the users are increased, then automatically that servers will also be increased. Next, every node in the cluster is able to handle requests for the same content or application. Every node, every computer in the cluster is able to handle requests for the same content or application. Every node in the cluster is able to handle requests for the same content or application. This type of distribution is typically seen in a web hosting environment. This type of distributions will seen in a web application environment, web hosting environment. This is the load balancing cluster architecture. WS means WebSphere application server. WebSphere application server instance 1, instance 2, instance 3. Those 3 instances will connected to the load balancer. If in WAS instance 1 only 50 users are there, then that 50 users we are connecting to one server. If in WAS instance 2 we'll have 100 customers, 100 users, then that also we are connecting to load balancer. So if the users are increased, then that load balancer will take care. That load balancer will take that load and will distribute to the different servers. Next is load balancing cluster diagram. So here we have different clients and we have active load balancer. In between we have load balancer and we have different servers. And so if the clients are increased rapidly, then automatically this load balancer will connect to the different servers. First, if we take only 50 users, then that load balancer will connect to only server 1. If the users are increased 100 to 200, 300, then automatically that load balancer will take the pain and will connect to the server 2, server 3, server 4, like that. Whatever the users are coming increasingly, then that load balancer also will try to connect to the different servers. If the users are coming down, then automatically that load balancer will decrease the servers also. If the users are decreased, then load balance servers also will decrease by the load balancer. So this is the clear picture of the load balancing cluster diagram. Next is high performance clusters. High performance computing uses generally supercomputers and computer clusters to solve advanced computational problems. High performance computing uses supercomputer and computer clusters to solve advanced computational problems. So HPC clusters are designed to HPC clusters are designed to exploit the parallel processing power of multiple nodes. HPC clusters are designed to exploit the parallel processing power of multiple nodes. They are most commonly used to perform functions that require nodes to communicate as they perform their task. For instance, when calculation results from one node will affect future results from another. Yeah. In high performance computing, generally we will use supercomputers. So that computer clusters to solve advanced computational problems. So HPC clusters are designed to exploit the parallel processing power of multiple nodes. It will take the parallel processing power from the different nodes, different computers, different systems. They are most commonly used to perform functions that require nodes to communicate as they perform their task. For instance, when calculation results from one node will affect future results from another node. Next is grid cluster. Grid-based clustering approach differs from the conventional clustering algorithms in that it is concerned not with the data points but with the value space that surrounds the data points. You know, so in grid clusters we have data points and value spaces. So these grid clusters concerned not with the data points but with the value space that surrounds the data points. That values are stored with surrounding of data points in grid cluster. So generally if we, for example, the grid means if you take mobile, then if you open that mobile, we have one message, we have one settings icon, we have one contacts icon, we have one memory icon. So those are all the grids. Those are all the grids. So if you take list, in list we have messages, memory, and context, like that it is there. But whereas if you choose grid option in mobile, if you choose grid option, then only icons will appear. Only icons will appear. Messages icon will appear, context icon will appear, memory icon will appear, settings icon will appear. So if you select list option, then message, contact, settings will appear. So that is the main example that we are daily using grid. That is the main example for grid. Next one is cluster application. Next one is cluster application. So we have different applications in cluster computing. Those are the Google search engine, Google search engine, petroleum reservoir simulation, and protein explorer. And next one is earthquake simulation and image rendering, weather forecasting. So these are all the applications we are using cluster computing, because with one system, with one computer, we cannot predict the forecasting. Okay, with one system we cannot predict the forecasting. So we are connecting different individual computers to the with the single network. We are connecting different individual computers with the single network connection. So then only it is possible to forecast the weather. It is possible to uh, calculate the earthquake. What is the Richter scale point? We'll calculate with that. And petroleum reservoir simulation also we are using cluster application. Next is benefits. Next is benefits of cluster computing. First point, awesome processing power. We have very good processing power by using cluster computing. The processing power of a high performance computer cluster is same as a mainframe computer. The processing power of high performance computing cluster is same as a mainframe computer. With many computers in a cluster, the processing power may even exceed that of a mainframe. With many computers in a cluster, the processing power may even exceed that of a mainframe. If mainframe computers, whatever the power they are consuming, if we connected many computers within one cluster, then the processing power may exceed that of a mainframe computer. Next, second one is cost efficient. So whenever if you want to purchase that systems, purchasing several good quality computers such as HP desktops at once is less expensive than buying supercomputer. You know, for suppose if we purchase any one supercomputer, it will cost 1 lakh 2 lakh. Then so for the same 1 lakh 2 lakh, we will purchase 4 or 5 good quality computers to connect with the cluster. You know, so that is very expensive than buying supercomputer, less expensive than buying supercomputer. The average PC today is a lot more powerful than the first mainframe computer. You know, if you take the generations, mainframe computer generations, the nowadays the PC today is a lot more powerful than the first mainframe computer. So present PC is the powerful than a first mainframe computer. If you take versions, then it is the mainframe computer is the obviously supercomputer. But if you take first mainframe computer, if you compare with the first mainframe computer, that nowadays PC is the better one to compare with first mainframe computer. Next is expandability. Third point is expandability. Many people feel that the best benefit of utilizing computer clusters is that they can expand easily by adding additional computers to the network. Expandability is very high because in cluster computing we will connect more systems, more computers. For suppose first we are connected 100 systems. Okay, now after that, if you want to connect more, then we will add additional computers to that network and we will work together. A mainframe computer has a fixed capacity and will only be able to handle so much power at a time. In mainframe computer, we'll have the fixed capacity. In mainframe computer, we'll have the fixed capacity to add the different mainframe computer. Whereas in general computer, there is no option like that. So we will add as much as we want. We will add as much as we want. So expandability is very high in cluster computing. Next is availability. Next is availability. When a mainframe computer fails, the entire system fails. Okay, now when mainframe computer fails, the entire system will fail. However, if a node in a computer cluster fails, its operations can be simply transferred to another node within the cluster, ensuring that there is no interruption in service. So, if we take mainframe computer cluster, then if one mainframe computer will fail, the entire system will goes to fail. If one mainframe computer will fail, then the entire system will fail. If if we take cluster computing, the general computers we are taking, general PCs we are taking. So if one computer will fail, its operations can be simply transferred to another computer within that cluster. Those operations will simply transfer to another computer within that cluster. So will not transfer to another cluster. Within that cluster only, that computer operations will transfer to another cluster, ensuring that there is no interruption in services. There are no interruption in service. Like that, that information will transfer to another system if that system fail in cluster computing. Compared to mainframe computers, it is not like that. If one mainframe computer will fail, the entire system will fail. Next is limitations. Limitations in cluster computing. Limitations in cluster computing. Typically, latency is very high and bandwidth is relatively low. Latency is very high, means the performance is very high and the bandwidth is relatively low. Why? Because if we connect 100 systems, only with single bandwidth we are connecting. For suppose if we take 100 bandwidth, we are connecting to 100 systems. Then for each system we will have only 1 Mbps bandwidth. Other system 1 Mbps bandwidth. Other system 1 Mbps bandwidth. Means that bandwidth is relatively low, but the performance is very high. And currently there is a very little software support for treating a cluster as a single system. Currently there is very little software support for treating a cluster as a single system. Next, problems exist in the interactions between mixed application workloads on a single time shared computer. If the problems are more, then we have to interact with the different mixed applications. So if we have if you are working different application, mixed applications, then on a single time shared computer it is okay. But if we not shared any application from one place to another place, then it is difficult. That is the limitation. Problems exist in the interactions between mixed application workloads and a single time shared computer. Next, conclusion. Cluster computing has become a major part of many research programs. Cluster computing has become a major part of many research programs because the price to performance ratio of commodity clusters is very good. Also, because the nodes in cluster are clones, there is single point of failure which enhances the reliability to the cluster. If there is any single point of failure, also the cluster whatever the systems are connected, that systems will work without affecting any disturbance to other computers, and they will share the information from one system to another system. So that is the best advantage we have in cluster computing. Yes. Cluster computing has become a major part of many research programs because the price to performance ratio of commodity clusters is very good, and also because the nodes in a cluster are clones, there is single point of failure which enhances the reliability to the reliability to the cluster. So this is about the cluster computing. Okay, now this is the cluster
Yes.
computing. Next we will see about grid computing for tomorrow class.
Okay, sir.
So any doubts, ma?
No, sir.
No, sir. సార్
So
మీరు మాకు నోట్స్ షేర్ చేస్తారా?
notes means this PPT only.
అదే సార్
Yes, sir.
పీపీటీ
అదే.
అయినా
PPT share చేస్తాం.
ఓకే సార్.
So చెప్పండి attendance. Roll number 1.
Yes, sir, present.
2.
Present, sir.
3.
ప్రెజెంట్ సార్.
Roll number 3. Present, huh?
ప్రెసెంట్ సార్.
ఉంది సార్.
4.
Present, sir.
5.
Present, sir.
6.
అబ్సెంట్ సార్.
అబ్సెంట్.
ఈ 6 కి ఏంటి ప్రాబ్లం? అసలు మొత్తం అన్ని క్లాసెస్ అబ్సెంట్ అవుతున్నాడు. లాస్ట్ వీక్ కూడా మొత్తం అబ్సెంట్ ఉన్నాడు. ఆయనకు అవైలబిలిటీ లేదమ్మా, మొబైల్ కానీ సిస్టమ్ కానీ
వస్తా అన్నాడు సార్.
నెట్వర్క్ అవైలబుల్ లేదా? లేకుంటే ఓకే, అంటే అక్కడే హైదరాబాద్ లోనే ఉంటారా లేకుంటే విలేజ్ లో ఉంటారా?
విలేజ్కి వెళ్ళిపోయాడు సార్. యాక్చువల్ అయితే హైదరాబాద్ లో ఉంటుండే, విలేజ్కి వెళ్ళిపోయాడు.
ఓకే ఓకే. నెక్స్ట్ రూల్ నెంబర్ 7.
అబ్సెంట్ సార్.
అబ్సెంట్ సార్.
7 అబ్సెంట్. 8.
అబ్సెంట్ సార్.
రూల్ నెంబర్ 8 వచ్చి వెళ్ళిపోయినాడు ఆయన. నెక్స్ట్ రూల్ నెంబర్ 9.
ప్రెసెంట్ సార్.
9 ప్రజెంటా? ఓకే, రూల్ నెంబర్ 9 ప్రజెంట్. 10.
అబ్సెంట్ సార్.
అబ్సెంట్.
10 అబ్సెంట్. 11.
Present, sir.
12.
ప్రెసెంట్ సార్.
Present, sir.
13.
Present, sir.
14.
ఎస్ సార్.
15.
ప్రెసెంట్ సార్.
15. రూల్ నెంబర్ 15.
ఇందాక ఉండే సార్ అటెండెన్స్ రాసినప్పుడు, ఇప్పుడు లేడు.
నెక్స్ట్ రూల్ నెంబర్ 16.
అబ్సెంట్ సార్.
17.
అబ్సెంట్ సార్.
అబ్సెంట్.
ఆల్సో అబ్సెంట్. 18.
అబ్సెంట్ సార్.
19.
సార్ 18 ప్రెసెంట్ సార్.
18 ఇప్పటిదాకా ఉన్నాడు సార్.
సార్ 18 ప్రెసెంట్.
18 present. Okay. 19.
Present, sir.
20.
Present, sir.
21.
అబ్సెంట్ సార్.
Absent.
21 కూడా అటెండ్ అవ్వట్లేడు.
సార్ ఇంకో 1 వీక్ లో వస్తాడు సార్.
22.
22 అబ్సెంట్ సార్.
22 అబ్సెంట్. 23.
ప్రెసెంట్ సార్.
Present, sir.
రుషిక్ ఇక్కడ కనిపించాడు. 24.
Sir,
అబ్సెంట్ సార్.
24 absent.
present for roll number 36 also he's having problems, so he went off by messing me. Sanit,
Oh.
36.
Okay. 24 absent. 25 detained. 26
అబ్సెంట్ సార్.
26 దేవరాజ్ ఈ రోజు కనిపించలేదు అతను. 27
Yes, sir.
అబ్సెంట్ సార్.
అబ్సెంటా? 28
ప్రెసెంట్ సార్.
28 roll number not visible.
రోహిత్ రేస్ ప్రెసెంట్ ఇన్ ద గన్ డే.
Okay. 29
Present, sir.
30
అబ్సెంట్ సార్.
Absent, sir.
31 32
Yes, sir.
33
అబ్సెంట్ సార్.
Absent.
34
అబ్సెంట్ సార్.
34 also absent. 36 present.
ప్రెసెంట్.
37
ప్రెసెంట్ సార్.
37 present. Okay. 38
Present, sir.
38 present. 40 present. 41
Present, sir.
1 present. 42
అబ్సెంట్ సార్.
Absent.
42 absent. 43
Present, sir.
okay. 44
Present, sir.
44 present. 45
ప్రెసెంట్ సార్.
Yes, sir.
45 present. 46
అబ్సెంట్ సార్.
46 absent. 47
Present, sir.
48
ప్రెసెంట్ సార్.
48 Srikar present. 49
అబ్సెంట్ సార్.
49 absent. 50 detained. 51 51
ప్రెసెంట్ సార్.
52
అబ్సెంట్ సార్.
52
అబ్సెంట్ సార్.
52 absent. 53
ప్రెసెంట్
Yes,
సార్.
sir.
53 present. 54 54
Absent, sir.
absent. 55
ప్రెసెంట్ సార్.
55 Roshan present. 56
ప్రెసెంట్ సార్.
56 present. 57
Present, sir.
58
Present, sir.
58 present ma.
Yes, sir.
59
అబ్సెంట్ సార్.
59 absent. 60
Present, sir.
16 సిరీస్ అబ్సెంట్.
next 16 series attend అవ్వట్లేదమ్మా.
సార్ నా నెక్స్ట్ మండే నుంచి వస్తాడు సార్.
నెక్స్ట్ మండే. ఓకే
21 16 సిరీస్ 40 సార్
So,
నెక్స్ట్ మండే సార్.
అదర్ క్లాసెస్ కి 50 మెంబర్స్ 45 మెంబర్స్ అటెండ్ అవుతున్నారు. నా క్లాస్ కి 40 మెంబర్స్ అటెండ్ అవుతున్నారు.
సార్ ఈరోజు అన్ని ఇంతే ఉన్నాయి సార్.
18 19 20 మెంబర్స్ అబ్సెంట్ ఉన్నారు. 20 మెంబర్స్ అబ్సెంట్ అంటే ఎంత? 36.
సార్.
36 AAD 43 మెంబర్స్ ప్రెసెంట్. థర్డ్ అవర్ సెకండ్ అవర్ 39.
sir.
42
ఫస్ట్ అవర్ 46.
ఈరోజు
ఫస్ట్ అవర్ 46 మెంబర్స్ ప్రెసెంట్ మా.
కాదు సార్. రాసి
SPPM
సార్ రాషన్ పంపిస్తాం సార్.
SPPM కదా ఫస్ట్ అవర్.
ప్రియా మ్యామ్ది.
ఇక్కడ నాకు ఆల్రెడీ మాకు గ్రూప్ లో పెడతారమ్మా మాకు కౌంట్. ఫస్ట్ అవర్ 46% ఫైనల్ ఇయర్. సెకండ్ అవర్ పైథాన్ 39%.
సార్ సెకండ్ అవర్ 40 మెంబర్స్ సార్.
సెకండ్ అవర్ 39 ఉందమ్మా ఇక్కడ, 39 పైథాన్ ప్రోగ్రామింగ్. థర్డ్ అవర్ ప్రతిమ మేడం ఏఏడి 43 మెంబర్స్ ప్రజెంట్.
సార్ ఫస్ట్ అవర్ 41 సార్.
43 కాదు సార్ ఏఏడి క్లాస్ లా.
ఓకే
ఫస్ట్ అయితే 46 ఏ నుంచి వచ్చిందో కూడా తెలియదు సార్.
సార్ 41 ఫస్ట్ అవర్.
సార్ 40s లోనే ఉంటది కానీ మరి 46 అంత రేంజ్ కూడా పోదు సార్.
ఓకే 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 మరి థ్యాంక్ యూ.
ఎస్ సార్.